All right, let's dive into something that is quite literally running the digital world all around you. Object-oriented programming. We'll call it OOP for short. Now, this might sound technical, but it's really the secret sauce behind your favorite apps and websites. And by the end of this, you're going to see just how powerful it really is.
So, let me start with a question for you. Think about the apps on your phone. Those epic video games you can't put down, even the software your bank uses. I mean, they all seem totally different, don't they? Well, it turns out they all share a core design philosophy under the hood. And yep, you guessed it, that philosophy is OOP.
But, to really appreciate why OOP is the solution, we've got to go back in time a little bit. We need to understand the huge problem that programmers were facing in the early days.
Back then, most programming was what we call procedural. Just imagine giving a computer one single, gigantic to-do list. The computer starts at line 1 and just goes step by step, all the way to the very end. And for really simple tasks, sure, that worked just fine.
But our ambitions got bigger, a lot bigger. And that simple to-do list, it exploded into thousands, sometimes millions of lines of code. It became this tangled, unmanageable spaghetti mess. You try to fix one little bug over here, and suddenly everything over there would break. Reusing code was a total copy and paste nightmare. It was pure chaos with absolutely no structure.
And this, right here, shows the shift perfectly. We had to move away from that procedural way, that one long, rigid recipe, to something totally new. A new way of thinking designed specifically to handle complexity. Instead of one giant scroll of instructions, OOP gave us a set of modular building blocks, kind of like digital Legos.
And that solution, the hero of our story, is object-oriented programming. It was created to bring order, structure, and frankly, a whole lot of common sense to the world of software.
So, the heart of this whole thing is the object. Now, don't just think of an object as a line of code. Think of it more like a mini program. It's this neat, self-contained little bundle that holds its own information, we call that its data, and it knows what it can do. We call those its behaviors.
Let's make this real. A car is a perfect example. In the old procedural way, you'd have variables like car color and car speed just floating around in your code, separate from everything else. With OOP, you create one single car object. This object holds its own data. Its color is red, its speed is 0, and it also contains its own behaviors or methods, like start, stop, and accelerate. It's a whole self-contained car modeled right in the code. So much cleaner.
So how does OOP pull off this amazing organization? Well, it all rests on 4 fundamental principles. I like to think of them as its 4 superpowers. Let's break them down.
First, you've got encapsulation. This is all about bundling an object's data and its behaviors together inside a protective bubble. Then there's abstraction. This is about hiding all the messy, complicated details and just showing the simple controls you need. Think about it. You can drive a car without knowing how the engine works, right? That's abstraction. Third is inheritance. This is awesome. It lets us create a new object based on an existing one. So a sports car object can inherit all the basic stuff from a car object, and we just add a new turbo feature. And finally, polymorphism. It's a fancy word that just means many forms. It lets a single action, like make sound, work differently for different objects. So a dog object will bark, but a cat object will meow. Same action, different results.
Okay, so when you put these 4 pillars together, you get some really incredible benefits. And this isn't just about writing tidier code, it's about completely changing how we build and maintain software for the better. As you can see, the biggest win here is reusability. Because of inheritance, once you build a great customer object, you can reuse it over and over, saving a massive amount of time. This naturally leads to better maintainability. Thanks to encapsulation, if a car's accelerator is broken, you know exactly where to look, inside the car object. And this organization is crucial for scalability. As projects get bigger, the code doesn't just collapse into that spaghetti mess we talked about. It stays organized, efficient, and because of that protective bubble, it's a lot more secure too. This quote just nails it. OOP is all about taming complexity. It lets you take a gigantic, overwhelming problem and just break it down into these small, logical, easy-to-manage pieces that you can build with, test, and use again and again.
So let's bring this all back home, because this isn't some abstract theory for computer scientists. OOP is the invisible architecture behind the digital tools you're using every single day.
Think about your phone. Every user profile is an object that holds your personal data. Every single post you see in your social media feed is an object. Even the buttons you tap, yep, those are objects with a specific behavior attached.
Oh, video games are a perfect example. Your character is a super complex object with data like health and inventory and behaviors like jump or attack. Every enemy, every weapon, every little potion, they're all their own distinct objects. And inheritance is everywhere. A big, scary dragon enemy might inherit all the basic traits of a simple flying enemy object, but with way more health and a fire-breathing attack.
And what about your bank account? It's basically the textbook definition of an OOP object. It holds data, your account number and your balance, and has very strictly controlled behaviors, like deposit and withdraw. That pillar of encapsulation is so critical here, it creates a secure bubble so other parts of the bank's software can't just randomly go in and change your balance.
And when you're shopping online, every product you browse is an object. Your shopping cart is an object that's designed to hold other product objects, and your customer account is another object. They're all working together seamlessly, passing messages back and forth.
So, let's just quickly recap the big ideas. The main thing is that OOP shifts our thinking from a long list of actions to modeling the world with objects. These objects keep their data and their behaviors bundled up together. This whole approach turns chaos into order, which makes our code reusable and way easier to manage. And it's no surprise that it's the foundation for so many of the world's most popular programming languages today.
At the end of the day, object-oriented programming provides this incredibly smart and intuitive blueprint for building things. It gives us the tools to model our complex world in a logical way. So the only real question left is, what will you build with it? Thanks for watching.